Good evening. This is Naz from NB Network Lessons. Hope everyone's doing okay and in high spirits. My today's topic of discussion under physics, lesson number 30, is motion with constant acceleration. In other words, if you are driving down the car, this right here, if you're going at the same speed, this is uniform motion. In other words, there is no acceleration. You're just going at 20 miles per second throughout the trip. You did not accelerate. However, if every second you're accelerating 3 meters per second square, that means you have constant acceleration. First second, you increased your acceleration by 3 meters per second square. Second, you increased it again by 3. Third second, you increased it again by 3, the acceleration. So your acceleration is constant. In other words, you're still picking up the speed, but your acceleration is very constant. Okay, so you're going increasing your speed like this and going faster slowly. Your acceleration is constant. So I drew this graph already in order to save time. So let's say at time 0, okay, your velocity is 10 meters per second. So in other words, when you started looking at the car, it was already going 10 miles per second. Acceleration is 3 miles or meters per second square. Okay. So basically, then at time 0, your velocity is 10 meters per second. That's the snapshot. That is when we started looking at the moving vehicle. After 1 second, acceleration is increasing 3 meters per second square every second. So then after 1 second, my speed would be 13 meters per second. After 2 seconds, my speed will increase by 3 meters per second because my acceleration is 3 meters per second square. So after 2 seconds is 16 miles per second. 3 seconds, 19. 4 seconds, 22 miles per second. 5 seconds, 25 meters or miles per second, whatever unit you like. So this is basically we have this chart based on the constant acceleration. Okay, put this down, constant acceleration. Okay, now let's see if we can draw a graph for that. Let's see if I draw a graph for speed versus time. Let's say this is my axis time in seconds, and this is my velocity in meters per second. Okay, so let's go ahead and see if we can draw the graph for that. Let's say we have, go ahead and put some tick marks. Let me see. Say 1, 2, 3, 4, 5. Okay, and then my velocity is, let's say we have 5, 10, 15, 20, and 25. So this is 25, 20, 15, 10, 5, and 0. Okay. Initially, when I started looking at the problem, we told you that we are looking at the car which is already moving 10 miles per hour per second. So then we started right here at this point, right? So after 1 second, where am I? How much fast am I going? 13 miles per second. So then I can say at 1 second, I'm right here. Okay. After 2 seconds, I'm 16. So I'm going to be right here, just above 15. 3 seconds, I'm 19, just a hair down of 20 seconds. 4 seconds, I'm going 22 miles per hour, 22 meters per second, which is right here. And then at 5 seconds, I'm at 25 seconds. 25 meters per second, right? So then what I can do is I can draw a straight line. Hopefully I can. I'm not a good artist, but I'll try my best. It's not a straight line, but pretend that it's a straight line. Okay. So now this basically tells me that every second how fast am I going. Okay. And with constant acceleration right here. Okay. So at first second, all right, I'm at 13. Second, I'm 16. Third second, I'm 19. Fourth second, I'm at 22 meters per second speed. And then at 5 seconds, I'm at driving at 25 meters per second. All right. So now let me ask you this. If you recall from my previous topics, and if you are a calculus student, you know the derivative of velocity is acceleration. Okay. And what is the derivative? Derivative is just the slope of the line at any given point. So let me ask you this. If this is a straight line, I know it's a little bit curved, but if it's a straight line, if you take slope at any point on this line, it's going to be same. All right. If I take slope right here, it's going to be same. If I take slope right here, it's going to be same. If I take slope right here, it's going to be same. And what is a slope? Slope is rise over run. And it is basically, in this case, acceleration. So let's say if we can find a slope, let's say if we can find at rise over run, and we use 1 and 13 right here. Okay. So then my slope would be Vf minus Vi over Tf minus Ti. Final velocity minus initial velocity, final time minus initial time. So that would be equal to Vf right here is 13. We started at 10. 13 minus 10. Final time is 1 second. Initial time is 0. 1 minus 0. So this is basically 3 meters per second square. And that is exactly what we gave you initially. We said acceleration is 3 meters per second square, and that is what we have. So in other words, we have this velocity graph, okay, which is constant because our acceleration is constant. If the acceleration was not constant, this graph could have been like this, curvy, or like a curve. However, in this case, we're discussing constant acceleration. So we take derivative of velocity, we get acceleration, and we showed you that we got 3 meters per second square, and that was given in the problem. So in this particular topic, that's all I have. In my next topic, which is going to be very, very important topic, we're going to introduce you with equations of motion. Okay, equations of motions which you're going to use throughout in physics. So please make sure that you come and listen to lesson 31 because that's really important. Thank you, physics lovers. Thank you, everyone. If you like the contents, please share and go ahead and give me a like. Take care of yourself.